A brown bear is standing in a river with a salmon in its mouth, and it is about to do something that looks wasteful. It bites into the head, tears out a strip along the belly, drops the rest in the water, and turns around for another one. It has eaten maybe a fifth of that fish. The carcass drifts away downstream, and the bear does it again and again, 40 or 50 times in a day. That is not laziness, and it is not cruelty. It is arithmetic, and by the end of this video, you will see that those discarded fish are feeding an entire forest. This is Kamchatka, a peninsula in the Russian Far East roughly the size of California, with more than 300 volcanoes, 29 of them active, and one of the densest populations of large predators anywhere on the planet. It is also one of the least accessible wild places left. There is no road connecting it to the rest of Russia. You arrive by air or by sea. And for most of the 20th century, it was a closed military zone that foreigners could not enter at all. That isolation is why what lives here is still here. There is a bear here that reaches the size of the largest brown bears on Earth, and it grows that big on fish. There is an eagle here that is the heaviest in the world, with a bill so large it looks like a mistake. There is an animal in the kelp forests offshore with the densest fur of any mammal ever measured, nearly 1 million hairs in a single square inch, because it has no blubber at all and would freeze without it. And there is one more. There is a small valley in the middle of this peninsula where animals walk in and die. Then the predators that come to eat those bodies die too, and then the scavengers that come for them. We are going to that valley at the end. Subscribe to Doc Wild 4K and turn on the bell. Every week we go somewhere most cameras never reach. Tell us in the comments what country you are watching from. Now let's go. Start with the salmon. Because in Kamchatka, the salmon is not a fish. It is the economy. All 6 species of Pacific salmon spawn here: pink, chum, sockeye, coho, chinook, and masu, which happens almost nowhere else. Somewhere between 1/5 and 1/4 of all wild Pacific salmon on Earth are born in Kamchatkan rivers. They hatch in fresh water, migrate out to the North Pacific, spend years growing, and then return to the exact river they came from, navigating thousands of kilometers of open ocean and finding a specific stream by smell. And then almost all of them die. Pacific salmon are semilparous. They breed once and their bodies shut down immediately after. The digestive system degenerates. The immune system collapses. Their flesh softens and their color changes, and within days of spawning, the river is full of dying and dead fish. That looks like a catastrophe. It is the single most important nutrient delivery event in the entire region. Because those fish spent years eating in the open ocean, and every one of them is a package of marine nitrogen and phosphorus being carried inland, sometimes hundreds of kilometers upstream, and released into a landscape that has no other source of it, which is where the bear comes in, and where that wasteful behavior starts making sense. The Kamchatka brown bear is among the largest brown bears in the world. Big males exceed 400 kilograms and in exceptional cases approach 600. The population is estimated in the vicinity of 10 to 15,000 animals, one of the densest concentrations of brown bears anywhere. They get that large because of the fish, and their whole year is built around it. In spring, they emerge from dens thin, feeding on grasses, sedges, roots, and winter-killed carcasses. Through summer, the salmon runs build. And in late summer and autumn, the bears enter hyperphagia, a physiological state in which they eat continuously, taking in tens of thousands of calories a day, laying down the fat that will carry them through 5 or 6 months of denning. When salmon are scarce, a bear eats every part of the fish. When salmon are abundant, it stops doing that. It strips the brain, the skin, and the roe, the fattest, most calorie-dense parts, and abandons the rest. Getting maximum fat per minute of fishing matters more than getting maximum food per fish, because the run is short and the winter is long. so the riverbanks fill with half-eaten salmon. And that is the part that changes the forest. Those discarded carcasses are dragged into the trees, scattered across the banks, and left. They are eaten by foxes, wolverines, martens, gulls, ravens, and eagles. What remains decomposes into the soil. Studies across the North Pacific have traced marine-derived nitrogen from salmon into streamside trees, into the insects living on them, and into songbirds nesting in them. Trees along salmon rivers can grow measurably faster than trees on comparable rivers without runs. The forest is partly built out of fish, and the bear is the delivery mechanism. That relationship reaches its most extreme form at one particular lake. Kurili Lake, in the south of the peninsula, is a caldera lake that hosts one of the largest sockeye salmon runs in Asia. Millions of fish enter it, and the bears converge, dozens of them visible at once along the shoreline and in the shallows, at densities that would be unthinkable anywhere else. Brown bears are not social animals. They avoid each other. Here they cannot because the food is concentrated in a small space, so a temporary hierarchy forms. The largest males take the best fishing positions at the river mouths. Females with cubs work the margins, and young bears take what is left. The fishing techniques are individual and learned. Some bears stand in fast water and pin fish with a paw. Some submerge their heads and hunt by sight underwater. Some wait below waterfalls and catch fish in the air. Some steal from other bears, which works until it does not. Cubs stay with their mother for 2 to 3 years, and what they learn in that time is technique. A cub that never watched its mother fish a particular way will not fish that way. And bears are not the only ones waiting at those rivers. The Steller's sea eagle is the heaviest eagle in the world. Large females reach 9 kilograms, with a wingspan approaching 2.5 meters, and an enormous yellow bill that is deeper and more massive than any other eagle's. The global population is small, on the order of 5,000 birds, and Kamchatka and the adjacent Russian coast hold most of them. They nest in trees and on cliffs near the coast and the salmon rivers, and their breeding is timed to the runs. They take live fish from the surface, they scavenge spawned-out salmon, and they take what bears leave behind. In winter, large numbers move south to Hokkaido in Japan, following the ice and the fish. And they are one of the reasons that discarded salmon matters. An eagle that heavy needs a lot of food, and a river full of abandoned carcasses is exactly that. Working the same carcasses on the ground and afraid of almost nothing is an animal with a reputation that is mostly accurate. The wolverine weighs at most around 20 kilograms, about the size of a medium dog, and it routinely drives foxes off kills, takes carcasses from wolves when it can, and has been documented killing prey many times its own weight in deep snow. Its advantage is engineering. Its feet are enormous relative to its body, spreading its weight so it can travel on soft snow that a deer or a wolf sinks into. Its jaws and teeth are built to crush frozen meat and bone that other scavengers cannot process at all, including a specialized upper molar rotated 90 degrees inward. It also caches food obsessively, burying meat in snow and under rocks and in permafrost, which functions as a refrigerator. A wolverine's survival strategy is not hunting well. It is finding, taking, and storing. It covers enormous distances doing it. Home ranges of hundreds of square kilometers, moving almost constantly. And in the same forest, an animal with the exact opposite strategy has quietly become one of the region's most successful predators. The sable is a marten, about the size of a small cat, with fur so valuable that it drove the Russian eastward expansion across Siberia in the 16th and 17th centuries. Kamchatka was reached in large part because of this animal. It hunts small rodents, hares, and birds, climbs well, and caches food like the wolverine does. Its winter coat is so dense that it can rest directly on snow without losing significant body heat. That fur nearly ended it. By the early 20th century, sable populations across Russia had collapsed from centuries of trapping, and recovery required decades of protection and reintroduction. The largest land predator here after the bear does not fish at all. Wolves hold territory across the peninsula in packs that are typically small by Eurasian standards, and their prey is reindeer, moose, and snow sheep. In winter, when snow is deep, the advantage swings toward them. A wolf's weight is spread across 4 feet, moving on packed trails it has used all season, and a moose breaking through crust with every step is burning far more energy than the animals following it. They also scavenge bear kills and salmon carcasses when the runs are on, which is one of the few times of year that wolves and bears are working the same ground. The lynx works the forest instead. It is built almost entirely around one prey animal and one condition: hares and deep snow. Its feet are enormous relative to its body and spread wide when it lands, which lets it stay on top of powder that a fox sinks into. It hunts by ambush from cover, and its population rises and falls on a multi-year cycle that tracks the hare population with a delay. More hares, more lynx kittens surviving. Hare crash, lynx crash. And the snow sheep hold the high ground above all of them, on cliffs and scree where a wolf cannot follow, coming down only when weather forces them to. Above the forests, on the volcanic slopes, the landscape changes completely, and so does what lives there. Kamchatka sits on the Pacific Ring of Fire, at the boundary where the Pacific Plate is being forced beneath the Okhotsk Plate. That subduction melts rock at depth, and the melt rises. The result is more than 300 volcanoes along the peninsula, with around 29 currently active. Klyuchevskaya Sopka is the highest active volcano in Eurasia at roughly 4,750 meters, and it erupts frequently. That geology produces something else, an enormous concentration of geothermal features. The Valley of Geysers, discovered in 1941 in the Kronotsky Reserve, holds one of the largest geyser fields on Earth, a river canyon lined with erupting vents, hot springs, and steaming ground. In 2007, a massive landslide buried a substantial portion of it under rock and mud, and a lake formed over parts of the valley floor. Some features were destroyed, some were later exposed again as the water drained. The valley is still active and still changing, and the animals use it. Bears feed on the warm ground where vegetation greens earlier in spring than anywhere else. And there is thermal ground where snow does not settle even in deep winter. That same volcanic ground does something to the plants that visitors rarely expect. Kamchatka's summer is short, a matter of a few months, and the vegetation responds to it with an intensity that looks tropical. Volcanic soils are mineral-rich, the ground is warm, and daylight in July runs long. Meadows on the lower slopes grow to head height in weeks, dense enough that a person walking through them cannot see the ground, and a bear moving through them is invisible until it is close. Some of the herbs here reach 2 and 3 meters. Umbellifers with hollow stems and flower heads the size of dinner plates, growing in stands that close over trails within days of them being cut. Below that, the berry crop matters more than it sounds. Blueberries, crowberries, and others carpet the tundra and the forest edge in late summer. And for bears, they are the bridge, the food that fills the gap between salmon runs and denning, and the fallback in a year when the run fails. A bad berry year and a weak salmon year in the same season is what pushes bears toward villages. And in the forest itself, the dominant tree is stone birch, twisted, low, resistant to wind and snow load, growing in open stands rather than dense canopy. Above the tree line, it gives way to dwarf pine, which grows sideways along the ground, lying flat under the snowpack all winter and lifting again when it melts. Nothing here grows tall by accident. Everything that stands upright has to survive the weight of several meters of snow every year. Off the coast, the volcanic geology continues underwater, and it produces one of the richest marine ecosystems in the northern hemisphere. The waters around Kamchatka, where the Sea of Okhotsk meets the Pacific, are cold, oxygen-rich, and heavily productive. Upwelling and nutrient mixing support enormous fish populations, and above them, dense kelp forests grow along rocky coastline, which brings us to the animal with the fur. Quick pause, because what is coming is the strangest part of this peninsula, including the valley I promised you at the start, where the ground itself kills. If this journey is holding you, subscribe to Doc Wild 4K right now. We go somewhere most cameras never reach every week, and subscribers always see the new ones first. Turn on the bell so you do not miss it. Now let's keep going. The sea otter has no blubber. Every other marine mammal in cold water, seals, whales, sea lions, insulates with a thick fat layer. The sea otter does not have one. Instead, it has the densest fur ever measured in any animal, up to about 1 million hairs per square inch in the thickest areas. That fur traps a layer of air against the skin, and that air is the insulation. The consequence is that grooming is not optional. A sea otter spends hours every day cleaning and aerating its coat because fur that becomes matted or contaminated stops holding air and the animal loses heat immediately. This is precisely why oil spills kill sea otters so efficiently. A small amount of oil destroys the insulation. And insulation alone is not enough. A sea otter's metabolic rate is roughly 2 to 3 times what you would expect for a mammal its size, and it must eat around 1/4 of its body weight every day to sustain that, which turns it into one of the most important animals in the entire coastal ecosystem. Sea otters eat sea urchins. Sea urchins eat kelp. When otter populations were driven down by the fur trade in the 18th and 19th centuries, urchin populations exploded, and the urchins grazed kelp forests down to bare rock, a state called an urchin barren. Kelp forest supports enormous numbers of fish and invertebrates, buffers coastlines from wave energy, and stores carbon. Remove one predator and the entire structure collapses. Where otters have recovered, kelp has come back with them. It is one of the clearest demonstrations of a keystone species anywhere in ecology, and the concept itself was developed largely from work on this coastline. The other animals of this coast are worth naming because the density here is unusual. Stellar sea lions haul out on rocks and islands along the peninsula in large numbers, the largest of all sea lions, with adult males exceeding 1 ton. The population declined severely in the North Pacific through the late 20th century, and the causes are still debated. Orcas work these waters year-round, in 2 distinct ecological forms that do not interbreed: fish-eating residents that live in stable family groups and hunt salmon, and mammal-eating transients that move in small, quiet groups and hunt seals, sea lions, and porpoises. They live in the same water and behave like different species. Gray whales feed in the shallow coastal waters off western Kamchatka, including animals from the critically endangered western population. The seals here are worth a moment because one of them barely exists anywhere else. Ringed seals, larga seals, and bearded seals all use these waters and the seasonal ice of the Sea of Okhotsk. But the one that matters most is the ribbon seal, a strikingly marked animal, dark with broad white bands looping around its neck, its flippers, and its body, a pattern that looks painted on. It breeds on drifting pack ice far offshore, which means almost nobody sees it. Pups are born white on open ice, nurse for a matter of weeks on extremely fat milk, and are abandoned when the ice starts to break. What happens to them afterward is poorly documented because the animals spend most of the year in open ocean and rarely come ashore. Its dependence on seasonal ice is also its exposure. A seal that breeds on drifting ice in a warming sea has nowhere else to put its pups. And on the sea cliffs, seabirds nest in colonies of hundreds of thousands. Kittiwakes, murreys, puffins, auklets, cormorants. All of them ultimately supported by the same productivity that supports everything else here. Winter here is long, and it removes almost everything. Snow depth in the interior can exceed several meters. Rivers freeze. The salmon are gone. Temperatures on the exposed slopes drop far below zero with wind that makes it worse. The bear's den. Pregnant females give birth in the den in midwinter to cubs weighing well under a kilogram, blind, nearly hairless, entirely dependent, while the mother lives on the fat she built during the salmon run and does not eat, drink, or defecate for months. She is nursing without eating. Every calorie in that milk comes out of her own body, and the milk of a brown bear is among the fattest produced by any land mammal. Whatever stays awake has to solve winter directly. The Arctic fox and the red fox both occur here, and the Kamchatkan red fox is large and heavily furred. Foxes hunt voles beneath the snowpack, locating them by sound and diving headfirst through the crust. The mountain hare turns white and stays active all winter, feeding on bark and twigs. And in the far north of the peninsula, wild reindeer dig through snow with their hooves to reach lichen, the same lichen-based winter diet that reindeer depend on across the entire Arctic. And one of the reasons the species can live where nothing else large can. Snowy owls appear in winter. Golden eagles hold territory year-round. And the ptarmigan, white and feather-footed, burrows into soft snow to roost, using the insulating layer that also shelters the voles the foxes are hunting. The whole winter system runs on the snowpack, as insulation, as cover, and as an obstacle, depending on which animal you are. Now to the valley. In the Kronotsky Reserve, near the Kikpinich volcano and not far from the Valley of Geysers, there is a small ravine that Soviet scientists documented in the 1970s after hunters noticed something wrong. Their dogs were dying there. It is now called the Valley of Death. The ravine is narrow, low-lying, and sheltered from wind, and volcanic gases seep continuously from the ground into it. Carbon dioxide, hydrogen sulfide, and other compounds coming directly from the magmatic system below. Carbon dioxide is heavier than air. In still conditions, in a depression with no airflow, it pools, and it displaces oxygen near the ground. An animal walking into that hollow does not smell carbon dioxide because it has no smell. It walks in, breathes air that is no longer breathable, and within minutes it is unable to leave. Birds die first, because they are small and closest to the ground and their metabolic demand is high. Then the bodies attract scavengers, foxes, wolverines, ravens, eagles. Those animals come down into the hollow to feed, and they die there as well. And then larger predators come for those bodies. Bears have been found dead in this ravine. It is a trap that resets itself. Every death produces bait, and the bait produces more deaths, and it has been running that cycle for as long as the gas has been venting. Researchers who work the site do it with gas detectors in the mornings when wind clears the hollow, and they do not linger. When the air is calm, the concentration builds again within hours. The scale is small. The lethal zone is a matter of a couple of 100 meters, and it is not unique on Earth. Similar gas accumulations exist in volcanic regions elsewhere, but the cascade of predators and scavengers dying on top of each other is unusually well documented here, and it is the clearest possible illustration of something true about this entire peninsula. Kamchatka is not a place where geology is scenery. Everywhere else you have been in this video, the volcanoes were the reason for the abundance. Volcanic soil and geothermal heat drive plant growth. Volcanic mineral input feeds the coastal waters. The caldera at Kurile Lake exists because a volcano collapsed, and it now holds one of the largest salmon runs in Asia. The subduction zone that builds the mountains also builds the shelf that makes the fishery. The same system that produced that lethal ravine produced the bears. Here is what I want to leave you with. Almost every wild place we cover is defined by what lives there. Kamchatka is defined by what the ground is doing. The bears are the size they are because of the salmon. The salmon are there in that quantity because of the rivers and the shelf. The rivers and the shelf are there because a tectonic plate is being forced down into the mantle and the peninsulas being built out of what comes back up. The forest is growing on fish that bears carried out of the water, on soil made of volcanic ash. And the same gas that comes out of that system kills anything that walks into the wrong hollow on a windless morning. It is not a landscape with animals on it. It is a machine, still running, still erupting, and everything alive here is downstream of it. Tell me in the comments which of these hit you hardest. The bear that eats a fifth of each fish and feeds a whole forest by doing it. The otter that would freeze to death without grooming its own fur. The eagle heavy enough to need a river full of abandoned salmon. Or the valley where the animals that come to eat the dead become the dead. Leave a like, subscribe if you have not already, and share this with someone who has never heard of this place. Until the next one, go somewhere wild. Doc Wild 4K.